I heard an answer. Yeah. So that's all G of A is. I mean, if we're all cool with G of X and F of X, we have no problem with G of X, F of X, that's all good. We should have equally no problem with G of A. Right? If G of X is X squared plus 2X, G of A is A squared plus 2A. Now the one thing you got to be careful about, when you put this in here, and then you put A squared plus 2A there, you have to put it in parentheses, so you actually subtract the whole damn thing. You're not going to subtract a piece of it. You got to subtract the whole G of A. You guys kind of with me a little bit?
Why is it A squared plus 2A?
What's G of X?
X squared plus 2A?
Why?
Because
That's what the hell it is.
Yeah.
So if G of X is X squared plus 2X, what's G of A? Okay. See, this is what's funny, man. I don't take that wrong. It is weird. I get it. I get that it's weird. But we're all cool with G of X. And all G of A does is it says, no, I don't want to use X. I want to use A. Okay. That's all it says. So if G of X is X squared plus 2X, I'm pretty sure every person in here would love to get this question. Is that true? Mm-hmm. If I gave you this question and you go, okay, because what would you do? And what would it look like now?
3 squared.
It would look like this, right? And then you would do what you can do. So what did you do? You replaced X with this. So of course G of A is replace X with A, replace X with 2A. Can you do anything with this though? No, because again, I just replaced it. And again, on the surface, you're all like, what the shit, man? We're just playing with letters? X, no, make it A. You know, it's like, what? But there is a purpose to this. I don't know if you guys realize, real quick, what is G of X? Before we learned functions, what would normally have been right here? What equals it? Say again?
50.
No. Before we learned functions, what letter would have been there? Y. Is that cool? Y equals X squared plus X. Remember that? So this is Y, right? Mm-hmm. Isn't this Y2 minus Y1, right? An output for this and an output for that. Y2 minus Y1 over X2 minus... It's the freaking slope between any point and a specific point. That's what that is. It's kind of neat to be really on that. And listen, is this really difficult now that you know what to do? You just have to take. What do we do with this? What do we do with this? Plug it in. It goes right there, right? And again, you put it in parentheses. Maybe? A little bit? So that you're going to end up with something that you can actually factor on the top, and you want the bottom to cancel. You want to try to reduce that fraction, right? And so that's not that bad. It really isn't. So don't freak out when I'm about to say. This is the first step in calculus. All calculus does. What can we get the slope for now? What can I give you and you can just tell me what the slope is? You can say the slope is 7. What does it have to be? Straight line. You with me? What kind of function is this? What would it look like? What would that function look like?
Parabola.
Parabola. Is there a single slope that describes a parabola? What slope means? Straight line. Why is the slope constant? Because it never turns. Are you guys sort of with me? I need something straight. If I want to say the entire slope everywhere is a number, 7, for example, that means it can never, the minute it turns, isn't the slope different? Yes? What is the parabola constantly freaking doing? Freaking turning. What the shit? So I can't say the slope is 7 for an entire parabola. That wouldn't make any sense because it's always turning. But we can say what's the slope at 2? What's the slope at -3? We can actually, because as you go on a roller coaster or something, right? You have a certain slope, but it's always changing. Yeah, shit. Right? Getting made. Anyway, I'm not going to suddenly start teaching calculus, don't worry. I just want you to know this is pre-calculus. So quite a few things we do in here won't immediately be like, oh, I see what that does for me. It's just stuff that we have to be able to do before we get into calculus. This is why this is, pre-calculus. So there will be times in this class where we're doing things and it doesn't immediately like, what would that do for me? Well, you don't know yet. In calculus, remember this stuff? Now we can do this shit to it. Oh, okay, maybe. You're all like, this is too much on a Tuesday after a long weekend. That's too damn bad. Anybody, any other questions, quiz or homework questions? Homework is happening, right? About half of you I haven't gotten any homework from, so give me some homework. Okay.
Oh, I didn't understand what 78 through 87 was asking us. I just didn't understand the question.
Is that the same section?
Same section, yeah.
This here?
Yes.
Okay, so it's saying on a graphing calculator, graph this,
Okay.
and then make the window this. Remember when we changed y max and y min and x max? So this one just wants you to do the domain. So I want to make x min negative 0.1, x max 0.1, and then just see what happens on the graph.
Okay.
Does that make sense?
I think so.
Now listen, real quick. Let's do 80 real quick. If the smallest x I could use is negative 10, what's the smallest output that I would get? If you put a negative 10 in, what do you get?
Square root.
No, don't
Or
overthink
cube
it.
root? No.
Don't overthink it. You're not solving for anything.
Okay.
X is negative 10, right? That's the smallest x could be. And that's going to make the y the smallest because I'm cubing it, so it's still going to be negative. So what's negative 10 to the third power? Well, negative 10 to the third power is just 1 with 3 zeros. So it's negative 1,000. And of course, what's the biggest output I'm going to get? Positive 1,000. So that's the range. Negative 1,000. So it's going to look like this. Wow, and go way the shit up there. Are you guys with me so far? Sorry? So for this problem, if you make x min this and x max that, what are you going to make y min and y max so you can see the whole thing in that window? You're going to make it negative 1,000 and positive 1,000. Right? Does that make any sense? So let's see what that looks like. Do I have? No, I don't. That's right. Just rawr. Okay, hold on. Other room is giving me the calculator emulator, but not this room. Oh yeah, can you see that? Let's see. All right, I'm pushing the button to do it. Focus. Okay, so if I put in there x cubed, at zoom 6, okay, so I'm going to get your standard thingamajig, right? Now if I go in and make the window, so it's already negative 10 to 10, but do you see how I can only see this little sliver of it? If I want to see where this goes way over here, I have to be able to see all the way up to 1,000, because that's what at 10 it's at 1,000. So if I go to window, make y min negative 1,000 like we said, and y max 1,000. Oh, I got some data in there too, isn't that neat? Got some leftover data. Anyway, don't worry, you're not gonna have those little boxes. I just gotta turn my data stuff off. Let me see. There we go. Wee-haw! See now, do you see how it completely goes from one corner to the other corner? You can see like the complete domain and range. So that when they make it 0.1, negative 0.1 to 0.1, you just take a second to figure out what's the output for negative 0.1, make y min that, what's the output for 0.1, make y max that, and then you can see the whole thing. Maybe? Maybe not? No? Screw you, Jeff. Arg. Okay, alright, I'm gonna move on. Okay, so don't forget, when you put a new function in, you can directly control what it shows you by going to window. That's what window's for. And real quick, this little Y scale, for example, it's going steps of 1, that's a lot, that's, you know, so maybe if I make it steps of 100, you can actually see little tick marks, right? Instead of just a brah, because it's trying to go steps of 1. Brah. All right. Maybe? No? Okay, all right. Oh, by the way, I still have to do that. I remember to do this. I did a graphing calculator workshop last week, and I recorded it so I can put it up on YouTube if I remember. So if somebody wants to remind me, that'd be great. But I want to do it in general anyway, so it's not your job to remind me. But when I do it, I can put the link on Canvas. Anything else from homework stuff? Okay. I'm an optimistic fool, so I'm going to pretend like that means everything's great. And again, what can you do if things are not great? What can you do if nothing's making sense? Can you do anything? Or is it just, you know, that's my life. What can you do? I know, this is a little PSA moment, so give it to me. What can you do if everything's going shitty? What can you do? Say again? Talk to me. Holy shit, yes. Have a little musical interlude, and music is great, right? Listen to music. Go outside and scream, and let the neighbors worry about what's going on, right? Anything else?
Office hours.
Yeah, the office hours, so come talk to me. What if you just don't like me? What if you're like, that guy's an asshole?
Tutoring center.
Tutoring center, right? Hopefully some of those people you get along with, right? Okay, and if that doesn't work, if you can't talk to me and the tutors don't help you, well, if you can't talk to me, you should go see my chairs and say, man, this guy's got a problem. Can't talk to this guy, he's not approachable, right? You should go talk to my chairs, get me on the straight and narrow. All right, maybe. So you're not just dangling by yourself somewhere. You hear me? If it's going rough and you're like, I don't even want to tell them, that doesn't make any sense. That's my whole job, is to take whatever you can do and make it better, right? So if you can't do 2 minus 5, don't sit there and go, I'm not going to say that to him. Who the hell? I'm the guy. I'm the person. I'm the person you say that to, right? I'm not going to make fun of you. That's crazy. Maybe? Okay. Maybe? All right. And how can you figure out my office hours?
Syllabus?
Holy shit. Well, the syllabus just says go to Canvas. So on Canvas is my office hours with a map. A map showing you where I am at the times that I have office hours. It's insanity. Okay, enough. Sorry. So if there's nothing else, no other questions from homework, I want to do a little something. Let's first review a little bit. Yes, sir? Yes. Good call. I want to do just a little review of one thing, and then I'm going to unleash you on this little group work stuff. Blah, blah, blah. What was it? Oh, yeah. So let's say I'm given f of x is 2 over 1 minus x, and g of x is square root of x plus 2. Sure. Who could tell me what this would be? Let me do like this. F of g of 2. What does that even freaking mean? Yes?
First you plug in the 2 for g of
Yeah,
x, and
yeah.
then you plug in that entire
Yes.
equation into f.
So
of x.
fundamentally, this is saying, what do you get for f when you put this into it? And what is this? I don't know. So that's my first step, is I gotta know, and what do you almost always do in algebra? You almost always start from the inside and work out, yes? The innermost parentheses. So how do you figure out g of 2?
Solve it.
Plug a 2 in,
Yeah.
right? That's what g of 2 is. I just replaced g of 2 with what it is. Is everybody with me so far? Maybe? Does anybody remember what this is called? Anybody remember what this is called? It's okay if you don't, it's fine. It's called a composition of functions. This function is composed of another function. So we call it composition of functions. How important is it that you know that word? Not. I just wanted to see it. So f of what? Square root of 4. 2. And what's f of 2? So it gets 2 over negative 1, which is negative 2. Cool. So that's composition of functions. It's really not a new idea. Whatever's in here, I put it in there. Okay, what is this? I don't know yet. Let me figure it out, and then I can shove it in there, right? So here, you guys try this. Put this somewhere you can see it. Oh my God. What is... let me see. G of negative 1. Ooh, look at that. That's awesome. Or little g, I'm sorry. It's the same problem, right? I mean, it's not the same exact problem. It's the same exact idea. Go ahead and do it real quick. Right, so you do the inside first. And g of negative 1 says to put a negative 1 in there. And what do you get?
1.
Yes, square root of 1 is 1. And then g of 1 just says to put a 1 in here, and what do you get? Root 3. And then you stop. I like it. I don't want no decimals. If the problem was, how far away from school do you live, and you calculate it and get this, you can make it a decimal, because none of us are going to say, yeah, I live about square root of 27 miles away from, who are you? But for just a regular math problem, leave it as this. Give me a decimal. All right, how's that? One more thing with these. Let's see what you guys think of this. What do you think this is asking you to do? G plus F at, what do you got, Jeff? 7. What do you think that wants? Yes?
Plug in 7 to G and F and then add the...
Yes! You can rewrite this as G evaluated 7 plus F evaluated 7, right? What if that would have said times? Just put a times there. What if that would have said divided by? So it just means evaluate its function, and then whatever you get, do this to the numbers. So it says add what you get for G and F at 7. So G of 7 is? Square root of 9? 3. And F of 7 is? What's F of 7? Negative 1/3, 11. 2 over 1 minus 7, 2 over negative 6, negative 1/3. Anybody know what 3 minus a third is? 2 and 2/3, of course. It's 1/3 less than 3, so it's 2 and 2/3. Bam! All right, so let me give this to you. Let me, for once, finally shut the hell up and let you guys do some stuff.
Yeah, I did for value for negative x.
All right.
And then
Babe.
I guess for the domain range, that was like I guess that would be the same as the local min.
Give some mood lighting.
X's, right?
Yeah, I got negative 8, 4, and 7, negative 2, or negative 7, 2.
You put the brackets or the front two of those?
I think
All right, guys, let's take a look.
Well, because it's close.
It started off really nice. You can tell me very quickly why this is a function.
Vertical line test.
Ooh, I love it. There's a definition going on. And what's the visual test we use?
Vertical line test.
Vertical line test. So the vertical line test is just a visualization. Good Lord, I'm gonna drink this morning. That the definition, every x can have only one y. So every vertical line I can imagine will only go through this once. So there's no input that has more than one output. So passes vertical line test. Yes.
Yeah.
Let me put that on this so you can see what I wrote. Domain and range. Domain, of course, is which axis do you look at? X-axis. So what's the lowest x as an output?
Negative 8.
Negative 8. Do I include it?
Yes.
What would this be if I didn't include it? Open circle. I love it. And of course, what's the highest x as an output?
4.
4. And why do I use interval notation? This could be a very tricky question. Why do I use interval notation for this? You guys are like, because you said so? Have you been paying attention, Jeff?
To
Dig
show.
it. Because negative 8 to 4, is there anything in the middle of there that it does not include?
No.
It includes everything, right? The line is solid all the way through. So that's what interval notation is for. If I have an infinite number of things between two things, that's what interval notation is built for. If this was just a series of points, a point there and a point there and an ant there and a point there, you guys see that? Point there and a point there. There he goes. Oh, come on, walk on the y-axis. Ooh, oh. All right, well. Does that, you guys follow? So if it was just discrete points, I could not use interval notation, because interval notation means everything from this to this. All right, where is he? Oh, there you go. Now what about the range? Same idea, just look at the y-axis. What's the smallest output that I can get? Negative 7, right? And what's the highest output I can get? 2. All right. All right. What is f of negative 6? Yeah, you just look at input it for negative 6 as an output of 2. Well, now you're on me. All right. Where are you? So, okay, sorry. Ant's just getting all up in my business. Where is it increasing, decreasing? So really that question is, I was telling a student this, and I think it made a lot of sense. If this was a profit function, like this was like 8 months ago, 6 months ago, so forth, maybe this is a like in the future, when are things looking good for the company? When are profits headed up? From between what time period? From 8 months ago to 6 months ago, our profit was going up, yes? And we're like, yeah! Right? Maybe? So where does something happen is x. Where is it increasing? From negative 8, and I don't include negative 8 because I don't know what was happening before negative 8. Up to what? Negative 6 is where it stops going up. And I don't include that either because at the top of something, it's not going up or down, it's just turning. It's kind of resting there for a second. Okay. What about, is there somewhere else that it's increasing?
Negative 6 to 1.
No, negative 6 to 1, what's it doing? Decreasing. So where else is it increasing?
1 to 4, 7 to 4.
Yeah, from 1 to 4 is another location where it's increasing. Are you guys all with me? It's that simple, but it's a matter of when to look which way. So this will be 1, what did we just say, 4? Okay. Where is it decreasing?
Negative 6 to
Yeah, from -6 to
1.
1. And it kind of makes sense. Notice what this leaves out. -6 to 1, and that must be where it was decreasing because it wasn't increasing.
So we only write the x values for that?
So again,
We only write the x values?
exactly. Because I don't care what the profit was. I just care where was it going up. Where was it going down?
So was the y value be what?
Yes, y value is what? Right. So look at the next question. What is the local max value? 2. 2 is the highest output. It's the local maximum value. So when I say what, that's most often a y answer. When I say where, that's an x answer. Right? If you wanted to locate where the peak was, you would say at -6. Not what the peak is, where is it? Right? So here, what is 2? Where does it occur at x equal
-6.
-6? So what is the local min value?
-7.
-7. Where does it occur?
1.
X equal 1. You guys with me? Because that's going to be kind of important. And again, it's just a matter of which thing tells me what. So if I say, what are the profits at month 2? Okay, that's the output. If I say, where does a profit of this occur? That's an X answer. All right. Now, real quick, I really desperately want function questions like this to be simple, because can you just tell me in English? So domain is all the x values that have outputs. Another way to say it is all the x values that work. Looking at f, what cannot happen in that kind of a function? No, that's too specific. Just generally.
The denominator can't be
The bottom cannot equal 0. So let's write it in English. Bottom not equal to 0, right? That's for the f function. What's the bottom?
x plus 5.
X plus 5 can't be 0, so therefore x can't be -5. Bam! And in interval notation, that would be, I have no room for this, -infinity to -5, -5 to infinity. So you include everything from here to here, except you skip -5. It's a cool less than infinity, by the way. It just looks like a very relaxed 8, but that's not infinity. Can somebody tell me, in English, what must happen in G, or what cannot happen in G? What would make it freak out if the inside was negative? So what must be true? The inside has to be
Positive.
or 0, right? So the inside must be at least 0. There's the English, right? Inside, at least 0. So let's put it in mathish. What's the inside?
X is greater than or equal to 0.
No, come on. What's the inside?
Square root of 3.
No, that's not inside. Square root's the outside. What's the inside?
3x plus
3x
10.
plus 10. And we said that has to be at least, how do you write that in mathish?
Equals.
No, that's equal.
Greater
What's at
than or
least?
equal to.
Greater than or equal to. And then when you solve that, subtract 10, divide by 3, you get this. So as long as I put an x value that's bigger or equal to -10/3, why can it be negative? Why can x be negative?
Because it still comes out as,
One quick answer is because I'm adding 10 to this shit, right?
yeah.
So there's going to be some negative values that'll work. If I put a -2 in, isn't that bigger than -10/3? Because -10/3 is bigger than, it's smaller than -3. So if I put a -2 in, I get -6 plus 10. I get a positive number inside because I'm adding 10 to it. So it's possible for the inputs to be negative because it makes the inside of it not negative, right? Maybe?
Mhm.
Maybe? So I really want you to see what I just did. Whatever the hell the function is, just say in English, oh shit, this better happen. What did I just say? Let me write that shit down and then solve it. It's crazy. Maybe?
Would you put would you put negative infinity, comma, -10/3 for
Get careful. greater than or equal to negative 10/3. What's the smallest it could be?
Negative
No.
10/3,
Negative 10/3. Up to
infinity.
infinity. In fact, if you have the variable on this side, this points to where the infinity will go. So it's pointing that way, so the infinity should be on this side. Oh, this poor little dude. Is that alright, guys? Guys, is that alright? How do I do that one?
Plug in
Think
5
you
for
can,
both,
just push the whole thing. Yeah, plug in 5 into what?
into both of them.
Both of them, I love it. Don't take the X stuff and try to divide it and, oh my God, just plug a 5 into F. What do you get when you put a 5 into F? 19 over 10. And what do I get when I put 5 into G? 5. So I want to do 19/10 divided by 5. How do I do that? 19/10 times
1 over
1/5, which is
19 over 50.
19/50. It's done. Right? I'm gonna be a smart man. Okay, cool. Alright, so how do I do this one? Yeah, I gotta figure out what G of negative 2 is.
Two.
Yeah, G of negative 2 is square root of negative 6 plus 10 is 4. I get 2. And now I know what that is, so now this is asking F of this, which is 2. And when you plug a 2 into F, you get 8
1.
minus 1 over 2 plus 5. Is that cool? Crazy shit. Now notice one thing. What did we just figure out? Input of 2 for F gives me an output of 1. So right here, don't I already know this is 2, 1? I already did the work, right? So what is F of negative 2? I get negative 8 minus 1 is negative 9
-3.
over 3 is negative 3. And what does average rate of change actually mean?
Slope.
Slope, that's what it means. Do I have 2 points?
Yes.
Yes. Can I figure out the slope? Yes. So it'll be y2 minus y1 over x2 minus x1. 4 over 4 is?
1.
Holy shit. Okay. And then I think everybody's favorite was this guy. But it truly is the easiest problem on there in a sense, because all I do is I take G, which is the square root of 3 times something plus 10, and what is that something going to be now? Yeah, whatever F is. So I just put this whole damn thing in place of X. That's it. And then one thing I can do right away is just actually do this. Is that cool?
Yeah.
So, is that right?
Oh.
And that would be fine, and you can even combine these, you can make like denominators, but let's not worry about this. Second? I don't know, because I forgot. Thank you. Okay. Yes,
Can you just rewind a little? Where did the negative 3 come from?
negative
When-
3. Oh,
Solving negative.
Shabu? Shabu.
No, on the other one.
This here?
Yeah.
Oh, alright, what is f of negative 2? When you put a negative 2 in, what do you get? You get
Oh,
negative 9 over 3, yeah. Is that cool? So when I see average rate of change, I need 2 points. I need the beginning point and the end point. And whatever the function does in the middle, I'm just gonna go as the crow flies. That's a straight line. I can do slope formula to figure out the slope, because that's all average rate of change is slope. Okay, maybe? Okay. Freaky shit. Again, this was not a quiz. You did not have to come in here unknowing all of this stuff, but hopefully doing this will help you with the homework. So, let's do the last thing we'll do from chapter 3 before the test, which is the transformations section. Say again? Yeah, exactly. Oh my God, that was kind of awesome. Oh no. Okay. Okay. So let's do this. Let's do this. You guys get ready. Can you make good and I have if I was a student in this class, I would say to me, Jeff, man, get some freaking graph paper, dude, because I'm horrible at that. So you have to know yourself. Get some graph paper if you have trouble doing this and making a nice tick marks, right? So if you do a graph and it looks like this, is that going to be good, the graph you make, with the scale I've done? What's wrong with that scale? First off, it's not identified, right? But it also doesn't step evenly, so if it's supposed to be a straight line, it could end up looking like this, because you got this crazy big gaps and small gaps. Everybody with me? So you need them to be equally spaced, or close to it, if your graph is going to do what it's supposed to do. Okay, maybe. So, everybody, let's do this. Let's just do some basic function shapes. Let's do this first. This is your basic skills going into this section. You have to know what we're about to do. So, for example, x squared. So don't just tell me parabola. Give me a little more detail. So, what's kind of like the most important point to graph on a parabola? The vertex. What's the vertex going to be for x squared?
Positive.
0, 0. I love it. It's a standard parabola. It hasn't been moved anywhere yet. So it's 0, 0. Then a really good idea is to do something on one side and something on the other, because it captures how curved it is. So at 1, where is it? 1. And at negative 1, where is it? 1. So those are what I call my anchor points. So when we start lifting it and moving it, that's literally all we have to do. Each point, move it over, move it up, and then redraw the parabola. It's crazy. If you don't know the base function shape and some anchor points, you're not going to be able to do that. Okay, so there's the, oh God, hopefully your curves are better. What about square root of x? Anyone tell me what's the lowest input I could use?
0, 0.
Yeah, 0, right? And of course, when I put a 0 in, I get a what out? 0. What about 1? 1, 1. What about 4? 2. And obviously, you can see why I picked 4, because it comes out with 9. So those are my anchor points for a square root function. Are you guys with me so far? So if you remember the shape and you remember some anchor points, you just have to move the points and then redraw the shape. It's insanely beautiful if you know your anchor shapes and points to go in. Yeah. Oh, let's see, what else? What about, I'll just make another one. Who cares? X cubed. Anyone know what that looks like? Who to what? I don't know why I'm doing that. I'm just going to use. So 0, 0, right? What's 1 cubed? 1. And what's negative 1 cubed? Negative 1. So then it does this here. This is the basic shape of it, right? I could have done 2, 8. I just didn't feel like it. So my anchor points are, again, like negative 1, 0, 1. Some nice middle of the shape anchor points. You guys with me? I mean, this. So you have to know the shapes. You just have to. Right? What about absolute value? Say what? Oh, I'm sorry, I thought you said anatomy.
No,
It's a V, okay, gotcha. Yeah, because what's the absolute value of 0? 0, it's crazy. So 0, 0, what's the absolute value of 1? 1, what's the absolute value of negative 1? 1. It looks like a parabola, it's got the same anchor points, but of course we know it's not curved because it's not it's to a first power. So it's just straight lines. Weehaw. Weehaw. Okay. All right, maybe. That's pretty good. That's pretty good. Let me think. Nothing else is coming to mind yet. We're going to have other functions, obviously. So this semester, we are going to learn like trigonometry. We're going to have trig functions, and we're going to be able to move them around the same way. Sorry. Yeah. That's like a fourth power. Yeah. Fourth power basically looks like this, unless it's got extra terms, and then it could be like a W. Right? Okay. But we're not going to consider that as a base function necessarily for these transformations. Okay. You could be. So we got these. Let me put these over here. Stay with me. Okay. Oh, you're just as dirty. Okay. Oh, so what the hell does transformations mean? This is not suddenly becoming a self-help lecture or something. Transformers? No, we're not. Yes.
It just depends. Basically, you have to move it to left or right or up and down.
Yeah. All right. So let's do this. I think one of the easiest functions to kind of start with, believe it or not, is the square root function. So we know what a square root of x looks like. We know it's the base points, 0, 0, 1, 1, 4, 2. So what if I had this function? Yeah. So I could make an XY table, but we're trying to move past the XY table shit. We need to get away from it. We got to have a more nuanced sense of what this means. What's the lowest x I can put into this now? Negative 3, because that makes the inside 0. How does that relate to the lowest x I could use before? Before I could use 0, correct? Now I could go to negative 3, yes? Mm-hmm. So how does that relate? It just went back 3. So every point will move back 3. That's all this does. It has the same shape, except now when I put a number in. So for example, I used to put a 0 in to get 0. What do I put in there now? Negative 3. So that moved back 3. So what's the very first thing? Any input I put in, what's the very first thing that I do to it? In this function, when I put a number in, what's the very first thing I do to it?
Add 3.
Add 3. So can't all of the inputs be 3 less than they used to be? Because the first thing I do is add 3. How do I get a 1 in here now? What would x be? How do I get a 1 in here? Negative 2. How did I get a 1 before? 1. Isn't it 3 below what it used to be? So I really want this to make sense. Students get really confused because they see a plus 3 there, so why am I going back 3? Because all my inputs can be 3 less than they used to be. Because the first thing I'm doing is adding 3. I really want this to make sense. So when it's in with the x value, it has the opposite effect on the graph. Okay, maybe. So this would be a shift to the left 3. So what I can do is, I can graph the base function, and what I normally do is I use a dotted line, because this is not the answer, this is the base function. Then I just take each anchor point and I move it. How does each point move? Left 3. So this point goes 1, 2, 3. This point goes 1, 2, 3. This point goes 1, 2, 3. And then I redraw the shape. How do I check what I've done? Well, what does this say must be true at 1? What must the output be at 1? 2. What do you get when you put a 1 in?
1, 3, 4.
Square root of 4, which is 2. Are you guys understanding? You can actually check your freaking work. When you draw the graph, when you move it and draw it, you can take a point, make sure it works. Does that make sense? You can check your work. I know you have a graphing calculator too. You can do that too. You can just check your work on the graphing calculator. Why not? But don't copy that shit. So I'm going to always ask you to list the transformations. Okay. Yes?
How long do we have to shrink it?
Say again? Oh, we're getting there. We're getting there. We're
Yeah.
starting, we got to build.
My bad.
Okay. We're not there yet, trust me. What about this? So first off, is the transformation affecting x?
No.
Nope. In fact, can you see the original function? Yep, there it is. There's the original function. So that would be the normal picture that we made earlier. What am I going to do with every output? I'm going to make every output. Say again? Come on. Every output is now going to be down 2 from where it was. What's the output for this? What do I get when I put a 1 in? 1. Now what do I get when I put a 1 in? Did it go down 2? So if it's not inside with the x, it affects the y. So here, isn't that 3 affecting the x? Because it's in there with the x, isn't it? Do you guess? Isn't the 3 affecting the x? Yes. Is that negative? Is that affecting the x? Nope. It's not in there with it. In fact, if you just go with me for a second, remember when this was y? Yes? When we have written it like this before? Yes? Can I get that 2 to be with the y? How do we get the 2 to be with the y? Do what again? Add 2, yes, because it's subtracting. Isn't that affecting the y now? So if it's not in with the x, I could, you don't have to. Dear God, don't do what I just did. You could move it over to be with the y, right? And that's why it's affecting the output. So it moves it up and down. So if it's connected to this piece, if it's in there with the x, it will affect the x, left and right. If it's not in with the x, it's going to affect the output, y, up and down. So I'm going to take my base graph, so here's my base graph. I'm going to make it dotted because that's not the answer. And I'm going to shift every output. It's going to do what? Yeah, so what's the transformation here is, the only transformation is down 2. It's going to take all the outputs, whatever they used to be, and make them 2 less. So where does this point go? Down 2. Down 2. Down 2. So I can check my work. When I put a 4 in, what do I get? Square root of 4 is minus 2 is 0. Sweet. I'm where I'm supposed to be, yes? Yes? Does that, let that be that nice, please? That's, all right, I know we haven't gotten to there's reflections and there's shrinking and so forth, but so far, this is nothing major. I really want that to be true. Okay. So let's look at some funkier shit. Yes? All right, before we do the funky shit, let me do one more thing. I'm going to erase these. You guys ready? Okay. Well, please erase those. Okay. Let's try this real quick before I introduce a different kind of transformation. So we got in with the x, plus or minus, is shift it left or right. Outside of the x, plus or minus, move it up or down. That's what we have so far, right? So what about this here? What if I had f of x equals x plus 1 squared minus 2? How many transformations? What's the base function? Take the transformations out. Sorry, steady. X squared. It's going to be parabola. And I know my anchor points. So immediately I can graph the base function. Bam, bam, bam. There's the base function. And I make it dotted because it's not the answer yet. Yeah? Can you tell me what the transformations are?
+2 -1.
Yeah. In fact, real quick, if you had this problem, this doesn't really come into play here, what would you do last? Yeah, so in this problem, it doesn't really matter to be honest, but in general, you do follow order operations. You will do this last. So do the order operations. So the first transformation would be left 1, and the next one would be down 2. And then, this is almost too nice to believe. You just take each point and do that shit to it. Yeah? Isn't that crazy? That can't be it, Jeff. So take this point, left 1, down 2. Bam. Take this point, left 1, down 2. Bam. Left 1, down 1, 2. Bam. You can make whatever sound effect you want. How do I check that? Plug something in. So -2 is supposed to have a -1 output. So if I, right, you guys see that? This is -2, -1. So if I put a -2 in, what do I get? -2 plus 1 is? Squared is? -2 is? Which is what it's supposed to be. I feel pretty good. Maybe? In fact, what's the new vertex? What was the vertex of the original? 0, 0. What's the new vertex now? Yeah, -1, -2. Kick ass. In fact, can't you see it? -1, -2. You can tell the vertex right away if it's in this form. So can somebody tell me, what is the vertex for this? It would shift 7, right? So 7, and then we go down 11. Isn't that crazy shit? So if it's in that form, I can see the vertex. And isn't the vertex basically the most important point on a parabola? If I know where that is, and kind of like, I figure out the other side's easy. Maybe? Yes?
When is the y positive?
When is, I haven't really done, well,
Oh, never mind.
I mean, yeah, that was, yeah. So if it was plus, I just happen to not do, I'm sorry. It would just move it up. Yeah. Okay, maybe. All right, so again, I didn't do any new transformations yet. It was still a left and right, up and down. So let's do a different kind of transformation. So what about, let's do this. This will freak you guys out a little bit. Yeah, let me freak you guys out a little bit. How about, is this 4? I don't know. F of x equals the square root of -x. Yeah, sorry.
So like, when it's in the inside, why is plus to the left and subtraction to the right?
All right, that was, yeah, okay.
Like one thing I never.
So, real quick. What's the smallest thing I can put in there? 0. So it starts at 0, yes? What's the smallest thing I can put in there? -2, right? Doesn't it start at -2? Isn't that back 2 from where it started before?
Oh.
I really want this to make nothing but sense. All of my inputs for this can be 2 less than they were before because the first thing I do is add 2 to them. How did I get a 2 out of it? How did I make this equal to 2? What would x have to be? 4. What if I wanted this to be 2? What would x have to be?
6.
No, 6 plus 2 is 8.
-6.
-6 plus 2 is -4. How do I get 2 out? I have to make the inside 4, yes? So I used to have to use 4 to make the output 2. Now I use 2 to make the, isn't that 2 less than it used to be? That's why the whole thing moves back.
Okay.
I love it. I know your brain goes, I see +2, why the shit are we going back? Because all my inputs have to react to that. They can now be 2 less. Okay, maybe. So what the shit about this? Does anyone have a problem with this? Does anyone think this is not something we can do or something? Not that way. It's in with the x, correct? So there's got to be something about left and right. So let's think about this for a minute. For square root of x, what can I put into it to make sense? What's the smallest thing? 0. And then I go up from there, yes? Think about this. What's the smallest I can use? Well, that's a weird question. I can use 0 still, yes? Can I use 1? Can I use 1? If you said yes, I'm going to make you do complex graphs. You want to do complex graphs with imaginary numbers? I kind of wish you'd say yes, so that would be kind of. You do? Cool. See me out. I'm gonna give you a problem. You must. I can't put a 1 in. Is that cool? Because we're talking about real outputs. But I can put a -1 in. Yes. Because when I put a -1 in, what do I get?
1.
-1 is 1. I get a 1 output. What about -4? So all the inputs are now negative of what they used to be. So what does that do visually? Well, it used to be this. Oh, yeah. Now every input just reflects. This is a reflection around the y-axis, because now, and isn't that a left and right switch? So it's in with the x, that's going to be left and right. So 1 used to go to 1, now -1 goes to 1. -4 goes to 2. So it just takes this and mirror images it across the y-axis. So there's a mirror and the y-axis. If I wanted to reflect it this way, what would I do? It would have to be not inside, it would have to be outside. So I love it. Okay, shit. Hold on. Some of you guys are like, no. So if I had this, that is not inside with the x, it's outside. So it's going to affect up and down. So whatever the output used to be, it's now the negative of it. That's what that says. So if my base graph is this, I got my anchor points I could do. Yeah, there, Jeff. Now, it used to have a 1 output here, so now it's got a -1. It used to have a 2 output here, so now it's got a -2. Isn't that the missing piece of the parabola that fell over? Right?
And it becomes a flip over.
Say again? Yeah, so this would be a flip over the x-axis. Yeah. This is a reflection, so let me be more specific. Reflection around y-axis. This is a reflection around x-axis. Okay. People get tripped up about this because they just see it as more and more and more shit, whereas you really should see it as shortcuts. I don't want to make an XY table. I don't want to make an XY table every damn time I gotta. Isn't there a way to do it quick? Yeah, there's a way to do it quick. Okay, maybe. So you guys try this real quick before we do anything else. Do this. Where are we at? F of x equals negative x squared plus 1. Don't say anything, just try to do it. How many transformations? Don't tell me what they are. How many transformations are there? 2. There's 2, isn't it? Yeah, isn't it negative? What kind of a transformation is that? Reflection. So there's a reflection and there's a movement somewhere. So try to graph that. Start with a base graph and then move it and do stuff to it. You don't have to do it all at once either. You could actually do multiple graphs. Some people bust out the colored pencils for this, right? Those people I love. And I don't mean I hate everybody else. So you don't have to bust out the color pencil. That's fine. Okay. So just make sure everybody starts correctly. Which transformation am I going to do last?
Plus one.
Yeah, so that would do what to it?
Go up.
It would go up one. I gotta do that last, because order operation still is in effect. And what's the first transformation? Reflect around what?
X. Axis.
Yes. Okay. So I graph my base function. So I always got my little anchor points, right? And then I do, let's see, I'm gonna try to do it all at once and see if you guys are cool with it. So first thing I do is I reflect them. So this point goes to where now? So 0, 0 is still there. Well, let's start with 0, 0. 0, when I reflect it, it's still here, correct? And then I move, sorry?
Isn't that a problem?
Oh, I'm sorry. I was gonna make it a square root. Thank you, thank you. I went on what I was going to do instead of what I actually did. Bum, bum, bum. Let's try this again. I love you guys. You're all out there like, what am I doing wrong? You're all fine. I did something. So here's my base graph. Let's try this again. There we go. So always make that dotted because it's not really the answer. All right, let's try this again. So now, this point, for example, first thing it does is reflect. So now it's here, right? And then it's going to go up one. So it reflects, and then it goes up one. What does this do? Reflects, so it stays there, right? It's right on the mirror, so it doesn't go anywhere. And then it goes up one. What's this one going to do? Reflect, and then it's going to go up one. So now here's my parabola. It's going to open the other way, I know, because it's a reflection, so it should be down now. So it just made it down and then moved the whole thing up one. So you could do that in multiple steps. You could make multiple graphs if you wanted to. You guys see that? How do I check this? Well, when I plug a 1 in, what am I supposed to get? When I plug a 1 in, what am I supposed to get? 0. Negative 1 plus 1 is 0. So I can always check the work at the end. Okay, maybe? Okay. Maybe. Yes?
Like, why does x, I'm guessing x being negative makes it,
Being pinged by a subject.
I'm guessing that the x being negative makes it that you reflected on the x-axis, so how would you know, like, which axis to reflect it on? I guess is my question.
Oh, is that inside with the x? I really want this to make sense.
Yeah.
No, it isn't. It would look like this if it was inside with the x.
Okay.
See how that's in with the x?
Right.
This one is, I can cover it, and there's my x squared.
So what would it look like if you were flipping it on the y-axis?
This?
Okay.
Yeah. And what's interesting is, what is negative x squared? What is that?
Positive.
Yeah, negative squared is positive. Doesn't it stay x squared? Because what happens if I take this and I turn it? Don't I get the same thing? So that's kind of cool. Mathematically, if I took a parabola and I just rotated it, it would be the same damn thing, wouldn't it? There. If you put a negative in with the x, the square would kill it. You get the same picture. If I move it, still a parabola, still looks exactly the same. I love it. Good question. Okay. What else can there be, Jeff? Oh, shit. Well, so far we've added stuff inside and we've subtracted and added stuff outside, all that kind of stuff. What if I multiply stuff inside and outside? And you're all like, I don't want to do that. It's too bad. We're going to do it. So, for example, kind of start over here. What if I had this? Let's think about this. Let's think about it the same way we did before. The base graph would be the square root of x. if I wanted to make the output 2, what would I make x? 4, right? Make the output 2, and make x 4. For this one, if I want the output to be 2, what would I make x? 2, right? You guys with me? Okay, so one thing isn't enough though. Did I subtract 2? Probably not, because it's a multiplication, but let's do another one. If I want the square root of x to be 3, what would I make x? Well, that's a bad example. Well, it's not a bad example. If I want the square root of x to be 4, what would x be? 16. Right? Yes? What if I wanted this to be 4? What would x have to be? 8. How does that relate? Each time. How does that relate to this? How does that relate to this? 8 is what of 16? 2 is what of 4? 2 is not twice 4. Half. What's the very first thing I do to every input in here? If you put a 4 in, what do you do to it? Very first thing.
Multiply by 2.
Double it. Right? Isn't that the very first thing we do to any number we put in? So can't all of our inputs be half as big as they used to be? Just like we saw here. Before I had to put a 16 in to make it 4. Now I just have to put an 8 in to make it 4, because the first thing I do is I double it. Maybe? And again, what did I say before? If it's in with the x, it does the opposite of what it looks like. What is the 2 doing to the x?
Multiplying.
So it actually ends up cutting it in half. Why? Because I'm doubling my inputs. They can all be half as big as they used to be. That's why. So what does that do graphically, Jeff? I don't know. Yeah. So the base graph looks like the same one we announced the square root. Let me double check. It's the square root. Can't trust myself this morning. So it looks like this. But now, to get an output of 2, I just have to put a 2 in, not a 4. So this actually goes here. It cuts in half. 4 cut in half is 2. What's 1 cut in half? A half. So now it looks like this. So doesn't it look like somebody did this? Yes? Somebody went there. So the word is not as important. This is called a compression because of what it looks like. Doesn't look like somebody compressed it. This is called a compression. How important is it you know that word? Not much. It isn't that important to know the word. What's important is do you know what it does? That's what's important. You like it?
So the outputs stay the same, and then we,
Say again, sorry?
the outputs stay the same, and then the inputs get
Half, yes,
Okay.
exactly. I love it. So if there would have been instead, if there would have been a 2 on the outside, what would that have done? Like this. All right, Chief.
Inputs
Just
stay
get on
the
the side.
same, and the outputs get doubled.
Yeah, is it in with the x? Nope. So it's not going to be a left and right thing. It's going to be an up and down thing. So this one takes all the outputs, whatever they used to be. There's the original function there, right? And it doubles them. So it's going to make it stretch vertically. Let's see. All right, so my base function would look like
0, 0, 1, 1, 4, 2.
okay. So now all the outputs, this output was 1, now it's 2. This output was 2, now it's 4. This output was 0, now it's 0. Yeah. So it just stretched it. By the way, all right, let me see if you guys, is everybody cool with that? Let me make sure everybody's not 100% cool, but okay at the moment. Is everybody okay at the moment with that? Let me ask you this. Square root of what is 2? 4. Okay, that's amazing. That's deep. All right. Doesn't this, so this is totally a stretch. You guys agree? stretched it up, yes? Think about it, doesn't it also look like I compressed it? I pushed this back here so now it's there, right? I don't want this to confuse you, but can't I write this as this? Aren't these the same? What's the square root of 4? 2? Do you see how either way I look at it, I get the same graph? If I stretch it, I get the graph. If I compress it by a fourth, from 4 to 1, I get the same graph. That last part wasn't that important. I just wanted to point it out right now. Right? Okay, maybe. I don't know. That might have been too much. Okay. How would I make this stretch? What would I have put in here to make it stretch instead of compress? I wanted to stretch it. Instead of a 2, I could have put a 1/2. If the first thing I do is cut all my inputs in half, don't they all have to be twice as big as they used to? Wouldn't that stretch it this way? Maybe? Are you guys with me a little bit? I know this is weird. I guess what you have to do, you have to try them out. This is section 3.5, I believe, by the way. Is that right? I suck at saying what section I'm in, so. Yeehaw. Let's see. Yes, 3.5. So 3.6 and 3.7 we're going to do for the next test, right? This first test is going to go up to 3.5. So what homework is due Thursday is everything up through 3.5. What if you're in section chapter 2 review still, and you're like, there ain't no way in hell I'm going to get through 3.5 done. You with me? You don't have to tell me if you're in that situation. I know some of you are, right? In fact, some of you guys are, man, I haven't done any homework yet. If you're in that situation, what do you think you should do to best get ready for the test? Study. That's awesome. In terms of homework, if there's no way in hell you're going to finish it, do as much as not even do as much as you can. Do every other problem, right? Skip some shit. You got to try some out from each section. Are you with me? Am I saying it's okay if you turn homework in incomplete? No. I'm saying you make it your own. You're like, the test is coming. I got to get practice. If you come to the test, you're like, I didn't do section 3.2, 3.3, or 3.4, or 3.5, Jeff. And I'm like, oh, you're going to die on those problems. So don't try to do every problem. If you're really far behind, don't do every single problem I assign. Do every other one or whatever. Does this make any sense? And again, I'm going to get that homework from you. I'm going to say, finish this shit. What the hell? And you're going to go, dude, I do what I can. Right? Because that's what I did. I think I told you this. I didn't finish my homework. There's no way in hell I could have finished. I was working 3 freaking jobs. I ain't going to finish that homework. But I did enough, so I kicked ass on the test. Maybe. Yes?
So our test is Thursday?
Yes, test is Thursday. So I moved it back a couple times. So test is Thursday. So tomorrow, I'm sorry. Before I forget, I've got the practice test. I will have an answer key for this tomorrow.
We can take this home.
Yeah. The practice test, you definitely don't have to turn it in, because I'm going to give an answer key. This will be part of our review tomorrow. Now, what was the other question?
How
Oh,
long,
we gotta hold on.
how long do you have to turn in homework corrections?
Oh, when are homework corrections due?
Final?
The day of the final.
Okay.
The first final or the second final?
The what?
Midterm or final?
Do we have a midterm?